afternoon, everybody. And this is my hypothesis and research on the EV shift in gears in India. And feel free to stop, disagree, or agree at every step, because a lot of this is mined from different research papers, and because the paradigm shift is about to happen. And it's not that we are full scale or full throttle here. We just about started here, because we have a situation where we have contraptions to highly sophisticated EV vehicles. So right from the bottom level three-wheeler rickshaws, which are built by one-man or two-man companies, two-man garages, to full-scale people like Morris Garages doing the work. So now there are opportunities everywhere. And the shift is not universal across all segments, but it is strategic to the particular EV that you want to target. So this presentation is covered on how a conventional gear manufacturing company can go from being conventional to EV compliant. It need not be to be a EV supply, part of the EV supply chain. The transition is not just infrastructure. It is mindset and agility. It can be a one-man shop, one gear shop, two gear shop, but the transition is the mindset. So, if you look at 5 years back to now, 5 years back it was 1 in 100, 1 in 200, or 1 in 1,000 that you would see EV. Now you go to a traffic signal, 1 in 10 or 1 in 20 is an EV. 5 years down the line, according to certain statistics, 1 in 10 or 2 in 10 will be ICE engines. Most of it will be EVs, either powered by batteries or powered by hydrogen. So that means the opportunity for us as gears manufacturers there's an ocean. We're not even, and in India, we are still about to, ascend the graph. So the opportunities are high. If you look at the challenges that EVs, when you become an EV manufacturer, what is the challenges that are there for an EV? Because the motors are running at 8,000 to 18,000 RPM, the gears have to be designed to take in that continuous load of 8,000 to 18,000 RPM. So there's challenges there. Then there is high continuous torque. Compared to an IC engine, there's continuous torque that is subjected to the gearbox. How do you handle that? And what are the knowledge base that you need to develop to handle that situation? And then there's a huge focus on NVH compliance. Because if you look at gearboxes that run with IC engines, the engine masks or kind of camouflages, hides the noise of the gearbox. Here, it is open. The motors are silent and they run at no noise. So the noise of the gearbox becomes visible, audible. It's exacerbated. So we have to focus on that compliance. And tighter tolerances for sure, because the gearbox is subjected to continuous motion, continuous revolutions. The tolerances need to be not only tight, it has to be in line with all the connected parts. So we'll go to that through each slide. This is the market opportunity, we all know it. Right now, the gearbox market for EV is about $500 million. And the axle, that is the one-line unit, that is the gearbox, motor, and the propeller, all in one line, is growing about 17%. Then we have single speed. Then we have two wheels and three wheels, which lead the volume. So these are the biggest segment are the three-wheelers. If you look at the three-wheelers compared to their motorized IC engines, are growing at about 70%. The next is the two-wheelers. Passenger vehicles and the commercial vehicles are still laggards, but they're high in value. Any questions so far? Okay, if you look at the EV drivetrain, we have a single axle. So we have an E-axle, we have a motor, gearbox, and the drive all encapsulated into one unit. So that is driving. So what is the advantages of this? Advantages of this is compactness, and you can buy it as a module. And when you are when you're part of the ecosystem of supply, the E-axle is one component, one module that you can integrator will buy, e-vehicle integrator. Now this is an opportunity, and this is how the paradigm will happen. That is, you will be an E-axle supplier. For a gearbox, when it comes to E-axle, what are the things that you need to focus on is noise and also the surface finish of the gears. In EV gears, especially the gears, especially with two-wheelers, there's a huge component of powder metallurgy gears that come in. That because of the volume that you have to supply and the compactness, the powder metallurgy will be an important concept that we have to understand and ensure it is optimal compared to the torque that it is subjected to. So in a two-wheeler and three-wheelers, a lot of the gears will be powder metallurgy, or there could be also polymers in it. So understanding that ecosystem, a supply ecosystem, will be something that a new entrant can take part in. Let's say I've just started becoming a EV supplier. I have a manufacturing company, a small manufacturing company, and I want to start venturing into EV space. What should I understand? What should I understand? I'm not a gear expert. What should I understand? I need to find a microgeometry expert of gears. I need to network with the person who understands that. Again, this microgeometry, a lot of people may disagree, but that person has to have experience for sure. But that person should also be able to mine data from AI, because a lot of data of microgeometry has been fed into AI, and it is not a standalone answer that you will give, because there are a lot of linkages. You have the drivetrain which has got the motor, coupler, and also the gearbox all integrated. Working in isolation will not work. That you can't just have a gear expert. Okay, the gear expert should work with the motor person. They should be agile enough to mine the performance data of both when they run together, how they work. Because there's so many combinations, you can't just work on physical formulas. You have to work on empirical and historical CAE-enabled data and come up with a solution for good microgeometry. So that means a critical component for you to have is a good microgeometry expert. Then a person who understands surface integrity. Now, when EV gears run, they work on very high contact. The Hertzian stress at tooth flank is very high, and also at the surface is extremely high. So when two gears running at very high speed and subjected to high torque, what happens is there are a lot of damages by micro pitting, and also surface damages occur. So an optimal selection of metallurgy, an optimal selection of the hardness is critical. But again, what I'm trying to stress here is it cannot be that you get an expert to give an isolated advice. Based on the application, based on the running of the vehicle, and based on how the vehicle is performed, the test piece is performed, the data will change. And there are many parts here. So you're working in an integrated environment where you have three parts that are running in. It cannot be just isolated gear data. It has to be how it performs with its prime mover. That becomes very critical here. In EV gears, the factor when you design EV gears, there's limited recovery for a gear from when it's subject to high torque. It's a continuous motion compared to ICE engines. So there's limited recovery, the gears should withstand so much of fatigue. And how do you withstand so much of fatigue? Depending on the case. It could be powder metallurgy, or it could be, a high quality carburized steel, which is heat treated appropriately. It cannot just be, here heat treatment cannot be an isolated black box. The heat treatment is a fundamental input to the closed loop production of the gearbox. So a heat treatment person is actually, heat treatment is one of the process constraints and inputs to the whole process. So the the heat treatment person is not outside, it's inside. The data that comes in is input. And also during the process of the manufacture of the gear, if the heat treatment needs work, there should be data fed to optimize heat treatment. So it's the collaboration and agility here is more important because the volumes are going to be so high, and the flexibility and the requirement. They have multiple levels of EV, different, right from contraptions to sophisticated machines. So the combinations are much higher, going to be much higher than the past. So again, just continue this. Here the challenges, the new battlefield is transmission error, noise, micro level deviations, profile and lead corrections, and the loaded tooth contact analysis becomes mandatory. What is loaded tooth contact analysis? That is, it is classical contact plus contacts of bearings, shafts, and the gearbox as a whole that will impact the design of the gear when it is subjected to high torque input from the motor. So the understanding of this and data that you get from the CAE, that is computer aided engineering reports that you get from different machines, has to be analyzed again with an AI tool. Analyzed with an AI tool and with a microgeometry expert, and then you come up with the right combination design here for the gear, and especially the process design. I will stress on this again. In EV gears, especially the the four-wheelers and the commercial vehicles, trucks, the heat treatment of the gear has to be, you can't wait for a heat treatment to finish, come back, get the first piece, again go back, if it's not all right, do the second piece and come back. The input from the heat treatment optimized with sensors and inputs has to be continuously fed to the gear cutting expert. There should be a great handshake between the person performing the heat treatment and the person designing the gear. I'll stress on closed loop correction. Can anyone suggest what comes to your mind when I say closed loop correction? We spoke about that so far. Any thoughts?
So closed loop is your grinding part will get to the measuring machine, they will check, and whatever will be the deviations with your requirement, that will be automatically fed to your grinding machines. That is called closed loop.
Yeah, so that is one part of it. That's one segment of it. Thank you. The closed loop here is every process, right from gear cutting feed, the stress, the cutting speed, to the dimensions, to the heat treatment, to the grinding. All the data is shared across each other personnel, and is fed to the respective AI to give suggested plans what the outcome will be. Suppose you are in stage 2, you don't go on to stage 4 and come back to stage 1. Okay, there's a cost impact here, and there's also time to market that is here. So you have a surrogate layer, AI layer, continuously feeding information to you, and you plan. So agility is important. Working with a microgeometry expert is important, and also, understanding heat treatment is critical. All of our speakers have spoke of this, and we all know this. The future of manufacturing is going to have a digital twin. The digital twin is continuous data that mined with each operation, which is historical, and also creates a digital replica of the sub-process. Now, this may challenge physical data, may challenge in the wrong way, or possibly open new horizons. A good chance it will challenge you. It is still unknown. So but without this input, for a person, let's say I'm starting off I have the capex, I have the money to start a gearing industry, I have a expert in microgeometry, or I'm willing to experiment on this, I will work with a digital twin, because digital twin will have data which experts have already fed into. Okay, and it'll create this. Sorry, it'll have a part of the data that the experts have fed in. Then it'll kind of give you where you're going in your dimensions. You start from gear cutting with with the force applied, with the tool life. You go into grinding, it'll give you a replica how the gearing is and what is the hardness it has. It has any microstructure failures. All that will become suggestive, but it need not be accurate. But so the team has to get together and use that as an input and find where you want to go next. So there's been a lot of research done. Time to market when you use a digital twin without that, the time to market is there's a 50% advantage when you use a digital twin. Now, can you afford a digital twin straight away at your level? Maybe yes. It need not be huge capex. So understanding, the requirement of your digital twin, the kind of simulation required, what you can afford. A lot of them is free, but you have to explore and use that in your production life cycle. A lot of it is free. The capabilities are improved with this, and the scrap. There's been strong research suggesting that the scrap, when you use a digital twin, comes down by 50%. Generated scrap. So the name of the game is, suppose a person without gearing experience has an opportunity to supply EV gears. There is hope. You partner. So what you do is you partner with the right heat treatment supplier. You ensure that you use simulation, and you work with gear cutting companies and integrate the whole process. You can become an EV supplier. The next step would be to do the capex for in-house enhancement. So I started a company called Hitork recently. Then I thought, what would be my future if I start making EV gears? What would I do? And this is not only research paper, this is my hypothesis or my visualization, what I would do. At first, find out which segment do I want to be, make an entry in, a splash in. I can't do all because the capex is huge for all, and it'll not happen in my lifetime if I try to venture into all. Okay, so I'll pick up the segment. Typically, I'll pick up a two-wheel segment, or a three-wheel. Here, the two-wheel or a three-wheel, the robustness of the gear is much less than that of a commercial vehicle or a passenger vehicle, because it's more mass market. The cost is less, and we can venture into it. Then the next step, I will work with a microgeometry expert, and also work with the NVH compliant expert. I want to know, when I'm making the gears, is it NVH compliant? So that means I'll invest in certain tools to check the noise, vibration, harshness. And next, I will also partner with labs to ensure my parts could be checked. The next is to get the right measuring equipments, and third step is like the profile tester and all that. Profile tester, which nowadays is you can get things which are not very expensive. And then after that, the fourth step is to get the right machinery. When I reach the prototyping, my prototypes are past the acceptance level to start production. Then I will get the right gear cutting machines and the gear grinding machines. So this is my journey, and I think I'll be doing this. So this would be the trajectory that I'll have: move from gear supplier to a module supplier to E-axle partner. E-axle is you have a gearbox, a motor, gearbox, and drivetrain all in one encapsulation, working as one unit. And finally is to work with the option. Thank you. If you have any questions, yes.
So, sir, thank you for giving this fruitful session to us, because EV is the future, and being a market consultant, we also see the CAGR what we have showcased are in line, and I think that yes, this would be the future. And since this slide is very important, being a market consultant, I just wanted to know that the strategic entry path, what you have showcased over here, I'm okay with it. But what would be your go-to-market strategy, right? How you would be cracking the market, because you'll be facing the competitors as well, right?
It's a good question. What I'm learning here, right? So my strategy would be to find out an opportunity for myself for which segment I want to go to. It's two-wheeler or three-wheeler thing. Then I'll use my connects and go to that. I cannot do all segments in one shot. So I'll pick my go-to-market strategy is one segment. I'll go after that.
No, since you already shortlisted that you would be focusing on two-wheelers or three-wheelers, but
Yeah.
how you would be like selling your thing in the market? How you would be assessing your competitors in this market?
Correct. So I'll find out what quality level I have the capacity to manufacture. What quality level of that part, that vehicle will accept. If I can, there's huge impact of capex. I can't straight away go buy a high-end machine and start manufacturing. I have to enter that space. So I will buy the machine. I'll have the machine. I'll make the product prototype and see which segment will accept this quality level, because it's huge, right from bare bones quality to extremely niche within less than 0.001 microns is acceptable. There's opportunity for all. I'll go to that particular product and work from there. I need a ramp. I'll start in that ramp. Can I answer your question?
Yeah, I think yes. Thank you, sir.
Yeah, thank you, sir.
Do we have any more questions? Okay. Thank you. Thank you so much. A huge round of applause as I invite Anishka Raghunath to join me on stage to present the memento.